All right, this is problem 4.61. It's a car that decelerates on a flat surface without skidding and then on an incline going uphill. It says the deceleration is negative 3.5 meters per second squared in my problem. So if you think of the car, draw a free body diagram, it's going forward with some velocity, but it's decelerating backwards, or accelerating backwards, excuse me, so it's a negative acceleration. That means there's a net force in that direction, and if I draw a free body diagram, you have the friction force that's that way, Fg there, and Fn there. So F net is the friction force. So F net is equal to ma, and the friction force is equal to mu Fn, but Fn is equal to mg, because it's equal to Fg. So ma equals that. If you solve for mu, you get that it's equal to a over g, or negative 3.5 meters per second squared over 9.8 meters per second squared. Sorry, I don't need the negative there. Let me pause for a second while Sam brushes his teeth. Okay, so now the situation changes and you're going uphill, and you want to know what the new acceleration would be, or deceleration, based on using the same static friction coefficient. So let me clear this. And so now you're on an incline. Let me undo that one. I don't want to draw it that way. So you have an incline. There's your block on the incline. You are going to have friction that's acting down the incline, as well as Fg parallel. So in this case, F net equals ma, but F net is the sum of those two. So you have mg sine of theta, which is what Fg parallel is, and you also have the friction force, which is mu Fn. Remember, Fn is the same as Fg perpendicular. Fg perpendicular is mg cosine of theta. So that's going to equal ma. If I solve for a, divide the m over, that goes, and remember mu was equal to a over g, I think is what we said on the last slide. So if I cancel things out, let me rearrange it here. I think it's a over g times g cos theta, and this is your original a, that negative 3.5 meters per second squared, plus g sine theta. One thing I would double check is the signs. I don't think you have to plug in the negative a, because we already drew the directions here, so I would skip that part when you plug in a here, because it's going to be in the same direction. And what I would say is, if your answer comes out, a equals, let me do it real quick in my head, about 5.1 meters per second squared. The issue is it's backward, so technically the answer would be, would be negative, just like the negative 3.5. But in reality, you could keep the positive sign all the way through, because you're taking care of the negative with those signs there. Hope this helps. If you have more questions, let me know.